So, grade 7 girls, let us begin the lesson plate tectonics. That is lesson number 3, lesson number 2. Lesson number 2 from the restless earth. We have finished with earth layers and we'll start with plate tectonics. That is lesson number 2 here. Now,
the vocabulary words for this lesson are Pangea, seafloor spreading, divergent boundary, convergent boundary, transform boundary, and convection.
So you need to know this first. You need to know the meaning of the word divergent. Example, like in a normal road, when you're driving a car, you need to know about divergent boundary. You need to know about convergent boundary. You need to know transform boundary and convection. Pangea, seafloor spreading. These are the vocabulary words of these lessons.
Click each word to learn more about it. You already know that most of the dry land on Earth is in the form of large land masses called continents. But did you know what is underneath the continents? Are Earth's continents floating on a layer of water?
What do you think?
Click yes or no.
The Earth's continents, like what we are staying on, the crust, is it floating on water? What do you think?
No.
Good job.
It doesn't.
The continents are floating,
different than the
but
oceans.
not on water. In fact, all of Earth's crust, including oceanic crust and continental crust, moves around on top of another layer. In this lesson, you will learn what is going on beneath Earth's crust and why it is constantly in motion.
Why it is moving and what happens because of the movement. We are going to learn in this lesson that why is this moving and what happens beneath the earth crust and why it is constantly in motion.
At one time, most geologists thought that the positions of the continents were fixed in place. A few suspected that continents moved, but they could not prove that movement was occurring. Now geologists have evidence showing that the major continents were once joined together in one vast supercontinent, and that the continents are continually moving very slowly. This is known as continental drift. Click the pictures to learn how scientists support this theory.
Yeah.
Long ago, even before dinosaurs roamed, all the major continents were joined.
This is what, girls, when you had, like before, if you would have seen the map, okay, the main map of the world, all the continents, these what you see are separated, they were joined together. They were not like this, they were joined. There was not much space for the ocean here. Even before I'm talking about the dinosaurs, that time, okay, like even before the Mesozoic era.
Long ago, even before dinosaurs roamed.
Now you find the, like even here, girls, see, these were the continents. It started to separate little bit because of these tectonic plates, because of that movement of, maybe because of earthquakes, maybe because of many disasters or erosions, or because even I told you in the chapter erosion, how the water drifted away, or how the water took away the land from there, and then they changed the shape of the map.
Geologists noticed that the outlines of the continents seemed to match, as if they fit together like one giant puzzle. This gave them a clue that the continents broke apart from one large landmass.
These are matching fossils.
Paleontologists have discovered fossils of similar animals on different continents. This indicates that, at one time, the continents were joined, so that plants and animals could move from one continent to another.
Okay, what did the paleontologists, who are the paleontologists first of all?
Paleontology.
Do you know, do any one of you know who are paleontologists? So that means you will just see the slide, whatever I will show you. You need to ask me, girls, who are paleontologists? Any idea? Okay, who are biologists? Grade 7 girls, I'm talking to you all. Who are biologists? Biologist, biologist.
Who are those who
They study biology.
They study biology. Okay, good answer. What is biology?
Like animals and
Living things, study of living things. Correct. So similarly, they study something and they are called as paleontologists. Those, and here, what is the picture giving here? Fossils. So when they study about fossils, those people are known as paleontologists. They have discovered fossils of similar animals on different continents. Like example, if I find in Saudi Arabia same animal fossils and same animal fossils in maybe neighboring country like Bahrain, you will say that Bahrain and Saudi Arabia are very near to each other. Like that, phosphorus before scientists used to see the fossils very nearby. That means they could have easily traveled from one country to another because they were very near to each other. The continents were very close to each other, and that have shown that these continents were first joined. Okay, please ask me if you don't know even a single word. It's not that I'm gonna open the vocabulary. I mean, paleontology is not a English word. It's a scientific word. You need to ask me because even previously I've studied, but I'm sure you will forget it. So please, girls, concentrate. Look at the slides. Look at the pictures. I want to explain you with the pictures so that at least somewhat it is interesting. You know that these lessons are very dry. Even if that you don't ask me, you will be more bored in it.
Just have discovered fossils of similar animals on different continents. This indicates that, at one time, the continents were joined, so that plants and animals could move from one continent to another. Geologists have found that some mountains, minerals.
Now again, geologists, girls. Who are geologists? Any idea who are geologists?
they study rocks.
Ha, because you see rocks here. They study about all of the geography, about all the weathers, the climate, everything about. They have found some mountains, minerals about mountains. They study about the rocks, minerals, everything. Mountain, minerals, rock formations, okay, opposite sides of the ocean. Now, later on, when they were studying about some mountains, they saw these mountains which were on one side, they went to the opposite side in the map. So, how could this happen? Because of the ocean took away them to the other side. So, this was because of erosion, water erosion.
The continents are parts of enormous sheets of rock called tectonic plates. These plates are constantly in motion, and when the plates move, the continents move with them. Along the edges of the plates, they push toward each other, pull apart from one another, or slide past one another. The interactions of the plates vary depending on the location. Where the Nazca plate meets the South American plate, the plates are slamming against each other, causing the Andes Mountains to.
Like whenever something comes closer to each other, they overlap with them. That's what they're saying. Saying here that these plates they were overlapping. The American plate mixed with the Pacific plate, or the South American plate mixed with the Caucasus plate, and all these were happening, which changed the shape of the match, and they were slamming against each other, causing the Andes mountain to form. And which mountains were formed? and this mountain are found.
The movement of the continents is one effect of plate tectonics. Scientists discovered another important effect when they began making maps of the seafloor. Deep under the ocean, along the mid-Atlantic ridge, two plates are being pushed away from each other. As the rocks along the ridge spread apart, magma comes up from below and hardens into new rock. This process is much like a giant conveyor belt. As a result, new seafloor is formed. How does seafloor spreading work? Click each picture to find out.
Girls, please can you just give me 2 to 3 minutes? I
Between Earth's crust and core is a layer called the mantle. This mantle is composed of rock that is so hot it is slowly flowing in massive currents. These currents are what drive seafloor spreading. As the magma pushes up from below, it creates pressure that warps and stretches Earth's crust.
So what did they say you? That because of in the mantle, when it is heated up, it gives cracks here. And as the magma pushes up, it creates a pressure here that warps, stretches earth crust. And you can see this earth crust, which have been stretched, and you can see those cracks. And after that,
as the plates pull apart, they form a valley between them called a rift valley. The East African Rift is an example of a rift valley. In this example, the rift valley occurs inland. If these plates continue to pull apart, a new ocean may slowly begin to form. It is being formed as the African plate splits into two parts.
Okay, so this is how they split it, and the African plate had split it into two parts.
As crustal plates continue to move away from one another, new rock is formed from the molten rock rising up from the mantle. The plates may continue spreading apart, widening the rift valley. An ocean may begin to form here. The formation of a new ocean may take millions of years to occur.
How about the ocean today?
Seafloor spreading continues today under the Atlantic Ocean along the mid-Atlantic ridge. As a result, the North American and Eurasian plates are moving apart.
So now, it took many years, girls, for these, ocean plates to form. It took many years. That's what they're saying.
Seafloor spreading continues today under the Atlantic Ocean along the mid-Atlantic ridge. As a result, the North American and Eurasian plates are moving apart.
That means after many years, after 100 to 200 years, again the Europe and Asia will be getting more apart, and something else will getting, because you know that the size cannot change. If something is getting apart from one side, from the other side they're getting up closer. So even today, the Eurasia, that is, we are staying in the near Europe and Asia, and the America, the distance, it is saying that even today it is increasing. Between North American and Eurasian plates are still moving apart.
More than 225 million years ago, all the continents were joined together in one giant...
Can you believe this? Can you believe that this is how the map looked like 225 million years ago? Nothing was away from each other. Yani we could reach America maybe in 2 hours. We could reach the other country maybe in 5 hours. They were so close to each other. All were joined like this. This is how they are saying us.
225 million years ago. 150 million years ago.
They became somewhat this way.
65 million years ago.
And now presently.
Present.
See how it moved apart? They're showing that. It's getting narrower from here, and we can see the size will definitely, like this size, if it's here, 1 minute, girls. If this was the Earth, if this was the Earth before, and so everything was so close, now they are making us to understand that when they are going too far, they are getting in this way. Understood? Like they're stretching themselves.
Which of these statements is true? Click all that apply.
Come on. Similar shapes of coastline on distant continent provided evidence for continental drift. Similar rocks, they gave you evidence, or similar fossils, they gave you evidence, or similar rock on either side of mid-Atlantic ridge provided evidence. Now you have to say me which all provided evidence. Which one?
Rocks.
What else? Rocks. Okay?
Yes.
That's partly correct.
Okay.
Try again.
That means similar rocks on either side, similar fossils on distant continent, similar shapes of coastlines. So there we have three things.
Well done.
Okay?
Geologists have found many. Before you move on to the second part of this lesson, let's look at what you've learned about Earth's crust and how it moves.
What did you learn about Earth crust, girls? What layers were inside the Earth crust? What we studied about? L and A, what was that about? Remember LAM, L4? Lithosphere. And A for the mantle. Okay.
Earth's lithosphere is divided into tectonic plates. These plates are constantly moving because, underneath, they are moved by convection currents within Earth's mantle. The continents move because they.
You remember when I said you about convection currents last time also, how the heavier things goes and settle down, and the rocks, they come up. You remember?
They are part of the plates. The continents move so slowly, we cannot observe their movement directly.
Because of they are moving because of similar shapes, because of similar rocks, fossil formations.
Scientists have found evidence of their movement in their shapes. They seem to fit together like a giant puzzle. And across the continents, scientists have found similar fossils and rock formations, which show they were once joined together. The process of seafloor spreading supports the hypothesis of continental drift. Deep under the ocean, plates are being pushed away from each other. As a result, new seafloor.
This is how the new seafloors formed, girls, because they are pushing against each other under the sea. The process of seaflooring supports the hypothesis of continental drift. What is the hypothesis?
So far, you have learned that the continents are floating on Earth's molten rock mantle. They move slowly over time, as seen in continental movement from Pangaea.
So they are saying that they move slowly over time, as seen in continental movement from Pangaea to their present locations.
Now we will look at plate tectonics, types of plate boundaries, and continental drift in more detail.
So now we'll learn about what all? Plate tectonics and plate boundaries. Again, plate tectonics, plate boundaries, and continental drift. One by one, he's going to explain us, and we are learning about, again, plate tectonic, plate boundaries, and continental drift in details.
The Mid-Atlantic Ridge is the largest known example of seafloor spreading. But there are also other plate boundaries where seafloor spreading is happening.
Guys, here, see, they're giving you A, they're giving you B, They have given you C and D. What do you think, which boundary on this map, example of sea floor spreading? Where do you think the sea floor is spreading? It cannot be A and D, right? Where the sea floor is spreading, girls. What can you say? Which boundary? When I say boundary, you must see the corners. The sea floor is spreading. Any idea? Any guess?
C.
B, let us see.
That isn't right. Look for an area where the arrows are both pointing away from the boundary, showing the two plates moving apart.
Okay, he's asking you to look for an area where the arrows are pointing away from the boundary, showing the two plates moving.
C.
See? A, you were saying? Do they share? Okay.
C.
A, the arrows are both pointing away from the boundary. Okay, let us see A. Wrong.
That's not it.
Means it is C.
Look for it. Correct.
Understood? Away means it is C, because see, something which is away, it is stretching and it is trying to. Now here they're not trying to make the boundary get. There are A means they will come and overlap each other. C means it is stretching and trying to make the plates move apart. Okay.
Scientists realized long ago that Earth.
Anyways, let us stop here, and inshallah we'll continue tomorrow. Okay. Have a nice day. Please start preparing for your math quiz.
Okay.